This is an addendum to a video I'm currently working on about hand-wired amplifiers, where I'll be explaining what is meant by terms like point-to-point and class A, the construction considerations of an amplifier that's being wired by hand, and how it differs from the construction of a PCB-based amplifier. The amplifier that I'll be using to demonstrate all of this is the orange Custom Shop 50, which I currently have outside of its head shell so we can get some glorious gut shots. I figured that viewers might want a what do all the parts do, basic overview of how a valve amplifier works, but I didn't want that to be a 10-minute sidebar included in the main video. So this is going to be a standalone, unscripted piece of content that walks you through what's happening inside here. This will be a very simple point at the thing and explain what it does style of video. So if you are looking for something that's a little bit more in depth, that measures voltages and follows a circuit schematic and has animated diagrams to conceptualize some of the things that I'm talking about here, I already have a video about that on the AD30 from a couple of years ago. That will be linked below. So yes, please enjoy this look at the insides of this hand-wired orange amplifier, and if you do have any questions about this that you'd like to see featured in the main video about point-to-point and hand-wired and all that stuff, just leave them below and perhaps they'll get featured. Right, here's a top-level overview of this amplifier so you can understand what all the different parts are doing. This amplifier won't be able to do very much unless it's able to take power from the main supply. So let's look at its power distribution first. And this is a good point to bring up a safety warning. I've opened up this amplifier and I'm going to be prodding around inside it. Don't emulate what I'm doing here. I'm a trained professional. This is not connected to mains power. I know that these large capacitors are discharged at the moment. So unless you feel comfortable with live electricity, with components that may shock you even after the amplifier has been switched off and unplugged from the mains, if you don't know how to check and discharge capacitors, maybe don't do what I'm doing. This is just for educational purposes. I've opened this up so that you don't have to. Mains power comes into the amplifier here. This is our IEC socket for our kettle lead, and that gives us a live and a neutral line which passes across to the power switch. And if the power switch is off, nothing else in the amplifier gets power. So let's turn it on. With the power switch on, that allows power through to the mains transformer. Now the mains transformer sits directly below this section here. And that's all very important because we want to keep the power section, the power distribution, as far removed from the signal part of the amplifier as possible. And the reason you want to keep the power separate from the signal is because power carries a lot of current. And as the current goes through those wires, it generates electric fields around the wires. The very low current, low voltage signal wires are very sensitive to electric fields in their vicinity. So we want to make sure that all of the big current carrying wires, the power side that's generating those electric fields, is kept as far away from the signals as possible. And that's also why we see all of these twisted pairs of wire. We've got a send path and a return path for the power, and if we wrap those together, the two opposing electric fields cancel each other out. So wrapping these wires together, these twisted pairs, as tightly as possible helps to eliminate any of those electric fields that may go stray into the signal wires. And we also see that all of these twisted pairs are trying to run as close to the chassis as possible, including into the edges, into the corners of the chassis. And we do that because the chassis acts as a ground plane. We can see right here, there's a star point where all the different grounds come to one point on the chassis, and that gets connected and carried away to ground. So with our big power wires that are generating electric fields tucked into the corners of the chassis, that helps to get those electric fields sucked away to ground via the ground plane of the chassis itself. That's an effort to take the electric fields away before they can affect any of the weak signal wires. From the power transformer, we have different tappings that come off there, and that provides different levels of voltage to different parts of the amplifier. For example, we have a black tapping here that comes to the lamp, the indicator lamp that lets us know that the amplifier is powered on. This is a 6.5 volt incandescent lamp, not an LED. This is one of your old filament style bulbs in there. And that 6.5 volts also feeds the heaters on the preamp valves. So that's a small low voltage feed for different things that need low voltage, but we also have a high voltage feed that comes to through these purple wires to our high tension fuses and then onto our rectifier here. This elevated board here contains 4 solid state rectifier diodes. This is a solid state rectified amplifier, and this will change our AC voltage into a rectified AC. So it takes the negative portion of the waveform and flips it all positive. And from this point we pass through the standby switch or the warm-up switch, which disconnects high tension to everything else in the amplifier. That passes that rectified voltage to our 3 filter capacitors here. And the filter capacitors smooth out that rectified voltage into a consistent DC voltage. These 3 big blue capacitors, in conjunction with the choke, which sits underneath here somewhere. It's the smallest looking transformer on the top side. It's not really a transformer, it's just a big induction coil, but that is part of this filtering system to smooth out the DC. That then provides high tension voltage to different parts of the amplifier, including the anodes or the plates of the 2 EL34 power valves. That's the overview of how power is distributed through the rest of the amplifier. Using the mains transformer to tap off different voltages, it gets rectified and it powers the anodes of the power valves and, of course, of the preamp valves. Now let's move to this side of the amplifier so we can look at everything that's happening with the signal. Our guitar connects to the input here, which is the bottom of these jacks, and that goes straight to the first gain stage of the preamp valve, the ECC83. ECC83 preamp valves have 2 gain stages in them. They're essentially 2 triode valves inside one package. So from the input, we go straight to the first gain stage, and that just amplifies the signal raw without doing anything else to it. And then it passes it back to our circuit here. This is all of the capacitors and resistors that make up the essentially the voicing of the amplifier. It controls the gain staging, it controls the EQ, it controls the biasing for the power valves. So from our first gain stage, we go back to this portion of the board, which does some gain setting and some basic filtering, which then passes to the gain potentiometer, which is right here. That lets us control how much gain happens when it gets passed to the next gain stage, the second gain stage of the first ECC83 preamp valve. From that second gain stage, we pass back to the board and go through all of this part of the circuit, and all of these capacitors and resistors work in conjunction with the 3 potentiometers on the front here, our bass, middle and treble controls. Those set the EQ. And we also have an EQ foot switch in here, which lets us disable all of these, completely just bypasses this part of the circuit, these pots and this filtering stage. That's an interesting thing we're going to play with later on to find out just how much difference it makes to include an EQ section and what it sounds like when you pull one out and just go raw amplification from start to end. Now this EQ filtering section also includes the presence control, which is included with this amplifier, and you will notice that every wire that comes off of this main board and connects to potentiometers or connects to these preamp valves are these shielded wires. We want to protect the signal wires, these weak signals, from any other stray electric fields that might be inside this enclosure thanks to all these power cables that are floating around. Of course, we've tried to ensure that the power has these twisted pairs to eliminate as much of the electric fields as possible, and we run them as close to the edges of the chassis as possible for grounding, but it also helps to have these shielded wires. After the EQ section, we pass to the second preamp valve. Although calling it a preamp valve is a little bit disingenuous because this isn't more gain staging, this is a phase splitter. We're using the 2 different gain stages of this preamp valve to split the signal apart into its positive and its negative hemicycle so that we can amplify both of those separately. That's an important part of Class AB operation. From the phase splitter, we head back to this portion of the board, which sets the bias for the 2 power valves. And one of the gimmicks of this amplifier is this switch here, which allows us to switch between 50 watt Class AB and 30 watt Class A operation. Essentially, throwing this switch tells this part of the circuit how to bias these 2 valves to either have it amplifying all of the signal all of the time, or doing it in push-pull with one half of the signal being amplified by one valve and the other half of the signal being amplified by the other. The master volume control sits between the phase splitter and the output valves, and this controls how much of all of this amplification reaches the final output. Once these 2 output valves have done their amplification, they send the signal to the output transformer, which sits directly below the chassis here, which does the final impedance interaction before sending it to these connection points here, which output to either 16 or 8 ohm connections for the speaker cabinet. And that's the extent of everything that's happening inside this amplifier. Power distribution's over here with our solid state rectifier, our filter capacitors, and a choke that sits under here. And then we have the signal side where we have our main circuit, which passes our gain staging, our phase splitting, our EQ section, and a master volume before finally providing bias to these two power valves out to the output transformer and out of the amplifier. It's very basic, very simple, but you can see just how much work it would be to put this together by hand as compared to all these components and all these outputs being printed onto a circuit board. I've now flipped the amplifier the other way up so we can see all the large components bolted to the other side of the chassis. This largest transformer, that's our mains transformer, that's converting the mains electricity into different voltages. We then have the output transformer, this one here, that's dealing with the output from the power valves, impedance connecting it, sending it to the speaker cabinet. We have this small device here, which is the choke. That's part of the filtering system alongside these three big filter capacitors. Don't lick them, that's a bad idea. We have our gain staging here, that's our gain stage preamp, and this one is our phase splitter.